We're always glad when the weather forecast announces high pressure. If, on the other hand, low pressure threatens, we know that bad weather is approaching. The height of air pressure, which is what the terms high and low refer to, plays a key role for the weather. This was discovered by scientist Otto von Guericke in the 17th century. He developed the barometer, an instrument that measures air pressure, which he used to predict the weather. The barometer was only one of the many results of his research into the effects of air or air pressure. The experiments Guericke carried out were based on the discovery that it is possible to produce an airless space or vacuum. When Otto von Guericke began his scientific career, he was already 47 years old and a highly respected man. Guericke was born into a patrician family in 1602 in the city of Magdeburg. He studied law in Leipzig and Jena. He then pursued his scientific interests and studied fortress construction and mathematics in Leiden. But initially, the world of technology and science was only a sideline for Guericke. Other duties awaited him. In 1626, he was elected alderman of Magdeburg. Times were hard. The 30 Years' War was raging in Central Europe. As a free imperial city, Magdeburg was caught between two fronts. In 1631, it was besieged by imperial Catholic troops. Over 20,000 people were killed. Guericke's family survived. As a result of its near destruction, however, Magdeburg lost its independence. A year after the Inferno, Guericke came up with a plan to rebuild the city. In the following years, he promoted the implementation of his plan as developer and treasurer. Guericke eventually became one of Magdeburg's 4 rotating mayors and the city's diplomatic representative. In 1648, he was sent as an envoy to Münster, where an end to the 30 Years' War was sealed in the Westphalian Peace Treaty. Thanks to Guericke's negotiating skills, Magdeburg regained its independence, at least for the time being. A year later, Magdeburg's fate was discussed once again at the Imperial Diet of Nuremberg. Negotiations went on for several months. The diplomat Guericke took advantage of the long breaks in between negotiations to turn his attention to scientific research. Guericke lived in exciting scientific times. Copernicus and other scientists had fundamentally changed people's view of the world and their notion of the cosmos. But many questions still remained unanswered. The infinite space between the stars and planets in particular aroused in Guericke an inextinguishable yearning to explore the subject. What was this something? Was this space empty? Guericke was also a practically minded man. He was convinced that rhetoric and sophistry were of no use to the natural sciences. He wanted to prove facts through experience or sensual perception. Guericke considered experiments to be the key to his research. He wanted to explore the empty space between the stars by artificially recreating it here on Earth. To do this, he had to be able to extract air from a suitable container. But how? Guericke was familiar with hose pipes like those used to extinguish fires. Would it be possible to modify hose pipes so that they could pump out air from a container? But Guericke's scientific deliberations were repeatedly interrupted. Diplomatic duties called again, and negotiations had an unfavourable outcome for Guericke. Magdeburg lost its independence again and fell under the power of Brandenburg's electoral prince. Politically disappointed, Gericke returned to his hometown. He immediately turned his attention to scientific studies and experiments, using up much of his fortune in the process. His first task was to modify the hose pipes. Gericke's first pump was very similar to a water pump. He used it to perform his first experiments. He filled up a barrel with water and closed it as carefully as possible. Then he extracted the water with the help of his pump. Did this leave an empty space in the barrel? But Gericke had not managed to pump out all the water, and he could hear a noise coming from all over the barrel. Air was flowing through the pores of the wood into the space that had been emptied of water. This was preventing a vacuum from being created. Gericke set about improving his pump so that air could be pumped directly. By pulling back a piston, air could be sucked out of the container. When it was pushed in, the cylinder was emptied via a valve. What proved difficult was making the piston and valves airtight. The valves had to be opened and closed at the right time so that air could be drawn out of the container. The next time he used a copper vessel instead of a wooden barrel. After several attempts, he succeeded in drawing air from it. Gericke had produced a vacuum for the first time. Although it needed improving, his vacuum pump worked. One important experiment involved weighing the container before and after pumping. Gericke discovered that the air-filled container was heavier than the emptied container. In other words, air had a weight. It was heavy and therefore exerted pressure on everything on Earth. Gericke was fascinated by the force of air pressure. To demonstrate it more clearly, he came up with a spectacular experiment in 1661. He joined together two brass hemispheres with a leather ring and wax. He then pumped the air out of the enclosure. Four men on each side of the sphere were unable to separate the two hemispheres. Air pressure was holding together the hemispheres from the outside because air was no longer present inside the sphere. Gericke had finally proven that a vacuum could be produced and that air pressure could be extremely strong, something we do not usually notice because the surrounding air feels the same everywhere. With the help of weights, Gericke was also able to calculate the force needed to separate the two hemispheres. Gericke's research brought him increasing fame. He also found out more about the work of other scientists, including the experiments of Evangelista Torricelli, a student of Galileo. Torricelli had used a different method to produce a vacuum in 1643. Torricelli filled up a glass tube, sealed at one end, with mercury. When he placed it on a mercury-filled dish with the open end facing downwards, the mercury column subsided under its own weight. Above the mercury level, there was nothing, a vacuum. Torricelli also noticed that the liquid metal always sank to about 760 millimeters. His theory was that the weight the entire atmosphere exerted on the mercury in the dish pushed the mercury up the glass tube until the weight of the mercury column corresponded to the weight of the atmosphere. The French scientist Blaise Pascal picked up on these ideas. To test Torricelli's theory, he suggested measuring the height of the mercury column on a mountain. He believed that high up on a mountain, the mercury column would be lower because the air column above it was shorter. Pascal's brother-in-law climbed up the 1,500-metre high Puy de Dôme, and sure enough, the mercury column was 85 millimetres shorter than at the foot of the mountain. Torricelli was right. The mercury column in the glass tube proved very useful because this instrument made it possible to measure the height of a mountain above sea level. The barometer was named after the Greek words baros for weight and meter for measurement. Guericke made another observation with the barometer, namely that the height of the mercury column, in other words the air pressure, changed slightly with the weather. By measuring air pressure and air temperature, he made his first weather forecasts. Guericke realised that air pressure decreased at higher elevations. This took him back to his original deliberations about the cosmos. He was convinced that the atmosphere was not infinite, but that it gradually became thinner until it eventually disappeared into nothingness. In his book, Experimenta Nova, Guericke summed up his many discoveries in a new vision of the world. Apart from the material things created by God, he claimed that there is an infinite space in which all things are embedded. But Guericke continued to show an interest in practical applications. With his wind tunnel, a forerunner of the air gun, he demonstrated that air pressure can propel an object with a sensational effect. He also demonstrated another use for air pressure with his atmospheric lifting device. He attached a rope to a movable piston in a cylinder. This was attached to a lifting board via a winch. When Guericke sucked out the air from between the cylinder and piston, the external air pressure pressed the piston into the airless cylinder so that the board was lifted. This experiment proved to be groundbreaking for the development of steam and combustion engines. In 1676, Guericke retired from his position as mayor. 2 years later, he also resigned as alderman of the city of Magdeburg. He followed his son to Hamburg, where he died in 1686. Germany's first experimental physicist was buried in Magdeburg's Johanneskirche. His death was mourned widely. We listen to weather forecasts almost every day. None of these scientifically proven weather predictions would be possible without the discoveries and inventions of Otto von Guericke.